In this video, let us see about the B tree. So B tree is a self-balanced search tree in which every node will contain multiple key and has got more than 2 children. And here the number of keys in a node and the number of children for a node depends upon the order of the B tree. So for every B tree, they will first tell in question that what is the order of the B tree, and based on the order, the number of keys in every node and the number of children for a node varies. Now let us see some of the properties of a B tree. So here, when you construct a B tree, all the leaf node must be at the same level, and all the nodes except the root must have at least, that is minimum, it should have m by 2 minus 1 key and a maximum of m minus 1 key. Say for example, say that you have got an order of the tree to be as 3. So any node should contain minimum of m by 2. So 3 by 2 minus 1, it is 1.5. 2 minus 1, so 1 key. So it should have a minimum of 1 key and a maximum of 3 minus 1 key, that is 2 keys. So this is how you find out for every node what should be the minimum key and maximum key given the order. So this should be followed for every node except the root node. And now the number of children that the non-leaf node can have except the root node is m by 2 children. So minimum of m by 2 children is allowed for a B tree of order m, and maximum it can have m number of children, where m defines the order of the tree. And if the order of the tree is 3, then it can have a minimum of m by 2 children. So it is 3 by 2, it is 1.5, so approximately equal to 2. So it can have a minimum of 2 children and a maximum of 3 children. And now let us do one more example here. Say that we have got an order as 5. And now let us find out what is the minimum number of children that it can have. The minimum children is m by 2. So it is 5 by 2, it is 3. And now the maximum children that it can have is m, that is 5. And what will be the minimum number of keys? So the minimum number of keys is m by 2 minus 1. So it is 3 minus 1. So it can have, every node can have a minimum of 2 keys, and maximum keys is m minus 1. So m minus 1, it is 5 minus 1, 4. So this is how you can find out, given an order of the tree, what should be the minimum children, what should be the maximum number of children, and minimum key and the maximum key. Hope you have understood this. Now let us see an example for construction of a B tree. And for the first easier case, let us try to construct the B tree for the numbers starting from 1 to 10. So here there are certain rules which we'll discuss it once we construct. So now for order of the tree, say that it is 3. It can have a maximum of how many children? It can have a maximum of m children. So maximum of, it can have 3 children, and the minimum children is going to be 3 by 2. Already we have done this. So minimum of 2 children. And the minimum number of key that it can have is m by 2 minus 1. So it is going to be 3 by 2 minus 1. So minimum is 1 key, and the maximum key that it can hold is m minus 1. So it is 2 key. Fine. So every node can have only a maximum of 2 keys. That we should always remember. Now while constructing, we have to check out if when we insert the node one after the other, if the maximum number of key is reached, now we should perform the operation called as the split operation here. So what is meant by split operation is, say for example, now when we start constructing, let us have first the initial node. say we are inserting the node 1, and always remember the property as I've explained should be in ascending order. So next I'm going to insert the node, the value say 2, and this is the key, and this node has reached its maximum size. The maximum key that every node can hold is maximum of 2 key. Now when I try to insert the next value say 3, there is no space here in the existing set of keys. Okay, what should I do is I should split the node at its median into 2 nodes, okay, and push this median node to become the parent. Okay, so let us redraw this. Now my parent node will be 2, and as this B tree follows the property of the binary search tree, the leftmost will now have 1, and as it can at most hold 2 keys, we'll have an empty space here, and 2's right side would be node 3. Fine. And now let us insert the next node. It is node 4. So when I insert node 4, so come here from the root. So 4 is greater than 2, so I should move to the right part. So coming to the right, already I've got a space, so I'll insert 4 here. Fine. Now when I try to insert node 5, okay, so try to insert the key value say 5. Now there is no space here to accompany this key. So what do? I'll perform the split operation. I'll move this 4 to its parent. Fine. So when I move, I've got a space in the root node. So I'll write down 2, 4, and 2's left would be 1, and 2's right would be 3. And what would be, where would be this 5? Because as this 5 is greater than 4, now this 5 would be placed at the right of 4. Fine. Now let us try to insert the node 6. So it is the value say 6 is inserted, and now let us try out with 7. Now there is no space here. Now there is no space. What do? I'll make out the median node to move it to its parent. But even in parent node, it has already it is holding the maximum key of 2. So let me write down this. And now even this parent cannot hold, so I should again find out the median and move this median up to the parent. Now let us redraw this tree now. So now 4 will move as a root node, and now 4's left would be 2, and 4's right would be 6. Fine. And 2's left would be 1, and 2's right would be 3, and the 6 left would be 5, and 6 right would be 7. Fine. Now let us try to insert node 8. So 8, there is a space. Now when I try to insert node 9, still I don't have a space. So what should I do? I should make out a move to its parent. So when I make out a move, my tree is going to be 4, 2, 6, and 8. As there is a space, I can write down 6 and 8. Now this is 1, 2's right is going to be 3, 6 left is going to be 5, 6 right is 7, and now 9 is greater than 8, so 9 will become the right child for the key value 8. And next let us insert the node 10. So let us see that here we can find, as per the property, all this nodes, okay, all the leaf nodes are at the same level, and every node in the tree, okay, will hold a maximum of m children. You can see here what is the maximum children that it can hold is, it can hold only 3 children, and the minimum of 2 children. So you can see it will at least contain a minimum of how many children? 2 children, and a maximum of 3 children. Fine. And so this is all about, and all the key values in the node must be arranged in the ascending order. So this is just a simple construction of the B tree. Now let me and the main advantage of using this B tree is that this B tree can be used in disk access. So say that in order to minimize the disk access time, okay, since the height of this B tree is very low, you can use this B tree for accessing the disk very quickly. So that is one of the application where this B tree can be used. And let us take out one example of order 5. Say that these are the keys which is given. So if it is of order 5, the minimum number of children that it can have is 3, maximum children is 5, the minimum key is m by 2 minus 1, so 2 keys, and maximum number of keys that it can hold is 4. Okay, so let us now start drawing step by step. So let us start now. So the maximum key is 4. Fine. So first let us insert 3. So here the numbers are not in arranged order. So once we insert one after the other key, we should arrange it in ascending order. Okay. So that is more important. So let me write down first outside. So 3, 14, and next when we insert 7, so I should sort it now. So it is 3, 7 and 14, and then we have got 1, and now let me rearrange. So it is 1, 3, 7 and 14. So let us write down here 1, 3, 7 and 14. So there is no issues as of now till 4 keys. Now when I try to insert the next key, say 8, fine. So when I try to insert 8, it has not got any more space. So what should I do? I should first again rearrange this. So when I rearrange, it would be 1, 3, 7, 8 and 14, right? Now as we know that as there is no space, we should find out what is the median node and push it to the higher level and make it as a parent, right? So let us now do that process. So let us write down. So it is going to be 7 as a root node. And what would be 7's left? All the nodes which are smaller than 7. All the keys which are smaller than 7. So it is 1, it is 1, 3, and then I can place 2 more keys. And what is to be at the right of 7? It is greater than 7 is 8 and 14. Fine. So this is now the updated B tree. Now let us, so till this we have done, and now we should insert the next node. It is 5, right? So when I insert 5, so where can I insert 5? 5 is lesser than 7, so it should be inserted on the left side of 7. So I'll insert 5 on the left. So it is in 5 inserted towards its left. Okay, fine. Remember always the B tree when you construct, it should satisfy the property of a binary search tree. The leftmost node should always be smaller than the root, and the right should always be greater than the root. Okay, and now the next is 11. So for 11 it is greater than 7, so it should come to this part. So let me write down 8, 11 and 14. So let us redraw this. It is going to be 8, 11 and 14. Eight, 11, 14, and there is one more space that we can, one more key that we can insert here. Next is 17. So let us have 17 inserted here. Yes, there is a space, so I can insert 17 here. Fine. So let me redraw this. So it is 70. And now the next key is 13. So 13, when I try to insert here, it is again not in ascending order. It is a condition where we have to perform the split. So let us rearrange it. So 8, 11, 13, 14 and 17. So here this is going to be 17 has got the extra key. So let us push this 13 to the parent node, right? So when we redraw this, we'll have 7, 13 move to the parent. Now what would be 7's left? 1, 3, 5, and 7's right would be 8, 11, and now 14 and 17 is greater than 13, so we have to put it in the right of 13, so it is 14 and 17. Fine, hope you got it. Now what is the next number? Next number is 6. So 6 is what? Lesser than 7, so I should move to the left. So there is a space for this key to be inserted, so let us insert in this place. Fine. And next is 23. So for 23 is greater than 13, so I should move to the right of this. So there is a space, so we'll insert 23. Fine. Next is 12. So 12, it is lesser than 13, so I should move to the left of this 13. So there is a space here, so we'll just insert 12 here. Fine. And next is 20. For 20, it is greater than 13, so there is a space here. So let us rearrange this: 14, 17, 20, and 23. Let me redraw this. So this is going to be 14, 17, 20, and 23. Yes. Now, what is the next number? It is 26. So now let us try to insert this 26. So when I try to insert this 26, it is greater than 13, so I'll insert it towards its right. And here now again the maximum number of keys is reached. So let me push this 20 to the upper level, that is the parent. So let us redraw this tree. So this is going to be 7, 13, 20. Now 7's left would be 1, 3, 5, and 6. 7's right would be 8, 11, 12, and 13's right would be 14 and 17. And this 23 and 26 is greater than 20. So let me draw to the right of 20. It is 23 and 26. Fine. Now we have got one more node, 4. Okay, one more key, 4. So 4 is lesser than 7. So where can I insert this 4? 4 should be inserted over here. So let us rearrange this: 1, 3, 4, 5. And now 6 is the key which has reached the overflow. Now I should find the median and move this 4 to its parent, right? So what would be the updated tree is, final tree is 4, 7, 13, and 20. As there is a space here, you can just place the median value in the parent node. So 4, 7, 13, and 20. And then you have towards the left of 4 is 1 and 3. And towards the right of 4 is 5, 6, and next is 7. 7's right would be 8, 11, 12. Next 13's right would be 14, 17, and 20's right would be 23, 26. Yes. So this is the final B tree which satisfies all the properties of the B tree. Hope you got it. And you can try solving out inserting the key 16, 18, 24, 25, and 90. And when you try inserting this, you will get the answer as this: 13. 13's left would be 4, 7. 13's right would be 17, 20. And 4's left would be 1, 3, 4's right would be 5, 6, and 7's right would be 8, 11, 12, and 17's left would be 14, 16, 17's right would be 18, 19, and 20's right would be 23, 24, 25, and 26. So this is the final B tree that you can get once you construct it.